Good afternoon, everyone. My name is Vedant Goel, and I'm a PhD candidate at the University of Kentucky. And I work with Professor Eha. And I'm here to provide you the overview of the multi-modal optimization and simulation track. Previously, my colleagues have covered the community analysis research track. I will here provide an overview of the multi-modal optimization and simulation of the project, also abbreviated as MMOS, while my colleagues Hangzhou, Chris, and Yupe will further dive into the details of each research point. To start with, ideally, we expect that most of the urban areas are being well served by the transit. In low density areas where the transit service is infrequent or unreliable, the with high density transit corridors. It therefore provides the customer with a seamless multimodal mode of transportation. The operation of ODMTS and transit services can be together synchronized as well as optimized so as to serve a particular objective. In our case, it is maximizing ridership and minimizing congestion. However, due to a vast array of reasons, mainly personal preferences, absence of reliable services, and the total journey time to complete the trip, often such trips are not completed using these modes of transport. Micromobility services like ride hail proposes to fill such gap, first and the last mile gap by allowing people to take ride hail services from their home and drop at transit corridors. However, because of the flexibility to provide a door-to-door services, they often tend up to become the main competitors of transit services rather than a supporting stream. Take the case of the map of San Francisco County area, which I show here. What you see is a heat map displaying number of pickups in each TSZ zone of the SF County on a typical weekday. The darker the color, more is the intensity of the pickups. And what we see is much of the services pickups is in and around the downtown area, which are already better served by the transit services. So in this case, and just more often, ride hail services are actually competing with the transit services. Ideally, we expect that their usage is more prominent in the low density areas where transit services are either infrequent or not reliable. For example, the light green part of the San Francisco TSZ map will be the ideal locations where TSZ contribute, and they pick up the trips and then put it back. And moreover, the trip should feed the main transit line, which you see on the left, or any transit main corridor, which is nearby to the low density areas. So they should be like a feeder services to the main transit corridor, which has the plus ODMTS network. such as to serve low density areas. Second, how and why does the ride hail behaves in such an observed way, that is mostly operating and serving in the downtown areas, and can we map their behavior? And the third would be, can this behavior what we have observed and what we optimize in the point one, can it be understood and used in transit planning, and whether these patterns are transferable from one city to another. In this case, we utilize San Francisco in California and Salt Lake City, Utah as our pilot cities. So essentially, those research funds can translate into three main modeling questions. First, as you see in the top, is we simulate the multimodal transit system. That is, we are configure and optimize the routes and frequencies of transit services in a way that they are able to maximize ridership or social benefit or any other social benefit the city can identify. This will be further explained by my colleague Hongja. Second is to understand the behavior of the ride hail service providers. So that's the bottom part where we are simulating the ride hail driver behavior, and UFA will explain how we are mapping the ride hail services behavior and its operation. These two both become part of the third simulation, which controls the input and the output, which is where it interacts with the other agents or the other city travelers, and it is called simulating individuals' behavior, where we are simulating the city, a large-scale travel demand model at a city level, where each traveler is free to maximize its objectives, and this is done in BEAM, which is a travel demand model. All three interact with each other, and that's how the whole multi-modal optimization simulation track works. I will now pass on to Hangzhou, who will describe in much more detail about how he is simulating or his team is simulating the multi-modal transit system. Thank you.